So today we're going to start with rectangles. So you're going to flip to the tab that says rectangles on it and open it on that page, just like we did for parallelograms. We're writing on the tab that says rectangles. Okay, so this part that we are writing down first, you are copying, if you read in the upper corner there, on the left-hand side. So if you want to draw a line down the middle, we're copying on the left side of this flap first. Okay? All right, so the first thing we're going to do is talk about all 5 properties of our parallelograms. So remember, our 5 properties of a parallelogram were that, what? What were some of those? Opposite sides are congruent. What else? Opposite sides parallel. Opposite angles congruent. What about the other kind of angles? Opposite are congruent, but what about the other kind? Consecutive or supplementary. And then the last one is about their diagonals. What was that one? Bisect each other. Good. So your properties of a rectangle is the list we're making right here. Its first property is that it has all 5 properties of the parallelogram. So to save us from making that list of 5 again, just write that it has all 5 properties of your parallelogram. Okay. So draw yourself a rectangle and mark all of that information up. So we have marked here that this side and this side are congruent, as well as the 2 ends. Okay. We have that the 2 ends are parallel, as well as the top and bottom. And we have that the diagonals bisect each other. Consecutive angles being congruent, there's not really any, consecutive angles being supplementary, there's not really anything to mark for that. Opposite angles being congruent, you could give some marks for as well. Okay. In addition to having the 5 properties of a parallelogram, rectangles also have 4 right angles. So we don't really need to just mark that opposite angles are congruent. You want to add in 4 marked right angles. So opposite angles will be congruent. Still holds true. They'll both be 90. Consecutive angles are still supplementary because 90 plus 90 is 180, right? So still holds true, just happens that all of them are congruent in our rectangles. Okay. Then we have another property to add here, and that is that not only do your diagonals bisect each other, your diagonals are congruent. So the one running from here to here is the same size as the one running from here to here. Okay, and because our diagonals are congruent, that's going to create a couple of triangles that have 2 congruent sides, right? What do we call triangles that have 2 congruent sides? Isosceles. So underneath this property that you've written down, we're going to add a couple bullet points. Because these diagonals are congruent, that means we're going to have 2 isosceles triangles with congruent base angles. Okay? So we could be referring to the one on top and bottom. Those 2 triangles are isosceles. They're the same, right? And we also are going to have 2 more isosceles that are the same as well. So those are the congruent base angles for that one. And then I also have 2 more isosceles on the ends, right? And those 2 are the same with congruent base angles again, right? So the congruent base angles are the ones marked in yellow here. So because the diagonals were the same size and bisect each other, these 2 triangles are the same because of these 2 congruent pieces. And we know isosceles don't just have 2 congruent sides, they have 2 congruent angles as well, right? So we automatically know it's the ones across from those congruent sides. So here and here for the red triangles where the blue dots are. And then for the blue triangles, it would be where the yellow dots are. So we have 4 isosceles triangles, but only sets of 2 that are the same as each other, right? Clearly, these blue ones are not the same as the red ones. Okay? All right. Okay. Now we're going to talk about our ways we can prove a rectangle. So just like we did for our parallelograms, we wrote the properties down first. And then in the second list, we're going to write down all of the theorems or the ways we prove it. So on the other half of your flap, we're now going to make a list of the ways we can prove. Okay, before we do that, you don't have to write this down unless you want to add it on that other half. But why are the diagonals congruent in a rectangle? What do you guys think? It does create 2 right triangles. Anybody else? So the diagonals being the same is what part of my right triangle? The hypotenuse, right? Okay, and what theorem do you guys have for finding the length of hypotenuse? Right. Where your A and B are the side lengths of our rectangle, right? Well, yes, right. Because of our property of opposite sides being congruent, the A for this rectangle is the same A for this rectangle. The B, being the bottom of this, rectangle, not triangle. The bottom of the rectangle being the bottom of the triangle is the same for the other. So if you did Pythagorean theorem, whatever A and B are for one triangle, they're the exact same for the other. So A squared plus B squared will equal the same thing for either one, right? Okay. So that's exactly what you guys were just telling me. We would use Pythagorean theorem to find both. So what do AC and BD have in common? Like I said, you don't have to copy this part down, but they would both be the hypotenuse C. Okay, so this is what we're copying down on that other half. Okay, so this is our theorems, or the ways that we can prove that we have a rectangle. The first is if you can prove that your diagonals are congruent, that's enough to prove that you have a rectangle. So if you can prove that this line and this line are the same size, that's all you have to do. The second is what we call the rectangle corollary. A corollary is also kind of like a theorem or a postulate, something that we can use as a rule. And this one says a quadrilateral is a rectangle if and only if it has 4 right angles. So basically, if you can prove either of the 2 additional properties that we listed on the other half besides the ones that a parallelogram have, that's enough to prove you have a rectangle. So if you can prove diagonals are congruent, or if you can prove that it has 4 right angles, then that's enough to prove that we have a rectangle. Okay, after you've copied that down, in the top half of the flap, we're going to draw 2 pictures, just like last time. So go ahead and divide the top half of your flap in half. And we're going to look at 2 example pictures. Okay, so on the first half, I want you to draw this rectangle. So you're going to draw a rectangle, put 2 diagonals in it, and name it MNOP, and label this angle under the diagonal down here 26 degrees. Okay, and they say that what we're going to be doing is finding all of the missing angles in this figure. So first of all, what property do you guys think we should be using to do that? What are we going to start with? What do we know about the angles in our rectangles? They're all right angles, right? So that's probably our good starting point. So if we know that that angle down there is 26, and like you guys said, we're probably going to use that property that every angle is 90 degrees, what am I going to do with that 26 to figure out the other part of the angle? Subtract from 90, good. So we got our 90-degree angle, we subtract, and we're going to get that that piece up there must be 64. All right, and then in addition to knowing that all the angles are 90, we have some of those parallelogram properties about opposite sides being parallel, which would imply we would have some what angles? Alternate interior angles. So if this one is 26, I would know this one is 26, right? And if this one is 64, I would know this one is 64. Okay, we also know that all of these pieces, because of our diagonal, are congruent. Because it's a rectangle, all those pieces are going to have to be congruent because they bisect each other and the entire lines themselves are congruent. So I also can use that when helping me find some angles around the center here. Okay. All right. So because my diagonals are congruent, we know we've got our isosceles triangles, right? So just before we said that the base angles are congruent, right? So 26 here and here, where else is it going to be 26? Right, here and here, right at the top. Good. Okay. And we also know we've got two isosceles triangles on the ends. So if this angle is 64, so is that one, right? And a mirror image of it on the other side as well. So now all that's left is to find these angles here around the center. Well, we said that these were all isosceles triangles. What's the angle sum of a triangle? 180. And in this triangle at the bottom and this one at the top, we know two of the angles are 26, right? So what could we do to find the missing angle? Add those two up, subtract from 180. And I could do the same thing for the ends where we've got 64 and 64, right? So for the two isosceles triangles, top and bottom, what's our missing angle here and here? 128, right? And we automatically know the other is the same because vertical angles and because they're the same triangle, right? Okay? And then same thing for the ones on the end, all right? So what would be the missing angle for these two triangles? 52. There we go. Okay. All right, on the other half of the flat, we're going to draw this rectangle. And you just need to label it with the same letters. We're going to be finding GE and KH. You don't have to write down that sentence up there at the top, but you do need to label KE, which is this part right here. They said is 2x plus 3, so write 2x plus 3 on this segment. And for GJ, which is this entire segment, label it as 6x minus 14. So this entire diagonal and then this part of a diagonal. Sorry. All right, so we're going to need to solve for x in order to find GE and KH. So what could we set up so that we could solve for x? 4x plus 6, right? And how did you come up with 4x plus 6? Right, double that smaller one, okay? So we already went in and labeled. We double the smaller one to set it equal to the larger one. So exactly what he said. We doubled the 2x plus 3, and it became 4x plus 6. So now I have 4x plus 6 equals 6x minus 14. All right, and then when we go to solve, what are we going to do first? bring all the x's together. So I'm going to move that 4x over there with the 6x, or the 6x over with the 4x. And then we just divide, and we get that x is good. Okay. Now, not only did they ask us to solve for x, they also want the length of GE. So what should the length of GE be? How would I find that? And half of the 6x minus 14 would also be equal to the 2x plus 3, since this is a rectangle, right? So we're going to plug that in. And what do we get for GE? Very good. And then for KH, what are we going to do to find KH? What are we going to do? Double it. Yeah. If half of it's 23, the whole thing is 46. Okay. Next, flip to the rhombus tab. All right, we're going to do the same thing there. You want to divide it in half. We're going to list the properties on one half, and then the theorems on the other half. Okay, so for our rhombus, first listing the properties. First of all, it has all 5 properties of your parallelogram. Okay, so that's the first thing you need to write down. So whenever you draw your picture, you mark your opposite sides parallel and congruent, and that your diagonals bisect each other. Okay. In addition to that, so in addition to having the 5 properties of a parallelogram, it also has diagonals that are perpendicular. What does that mean? How is that useful? Very good. Very good. 90-degree angles at the intersection, points of the diagonals. Very good. So, if I have 4 right angles around the center, that's going to make me have 4 right triangles here. All right. And then it says, what conjecture can we make about this next one? Diagonals bisect the angles. So what does bisecting the angles mean? Cuts them in half, right? So if I've got a right angle here at the center, and then this angle has been split in half, that means that the 2 angles it was just split into are congruent, right? Okay. So those are all 4 going to be congruent, and those are all 4 going to be congruent. It's helpful for you to know what this means. You don't have to draw it as long as you're writing down the statements, but some people like to draw a picture too. All right, and so then they ask, you know, what does this mean for us? How is that going to be helpful? What do you guys think about the blue angle pair? We could. We also should know that that would mean, because of this 90-degree angle here, whatever they are, those are going to be complementary. So supplementary 180, complementary 90, right? So all those angle pairs are going to have to be complementary. Doesn't mean that they're 45 and 45, right? It just means whatever they are, they're going to have to add up to 90. Okay? All right, so the only 2 additional properties that we add here are that diagonals are perpendicular. Oh, sorry, we also have this one up here, 3 additional. And the 4 equal sides. Okay, so 4 congruent sides. diagonals are perpendicular, and then the third new property is that the diagonals bisect the angles. Okay? So all the properties of the parallelogram plus 3 more. Congruent sides, diagonals perpendicular, diagonals bisect the angles, which tells us the angles are complementary. So make sure you do copy down that bullet point there. Okay. On the next slide, we're going to be writing down all of the theorems of our rhombus. So this is all the ways you can prove that you've got a rhombus. All right. So first is by the rhombus corollary. Okay. So these are going to include that a quadrilateral is a rhombus if and only if it has 4 congruent sides. The next, if diagonals are perpendicular, then it's a rhombus. And the third is a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So basically, the 3 ways you prove that you have a rhombus are by the 3 additional properties. Okay, on the top half of the flap, we are also going to copy down pictures. I'll give you a second to finish copying these down. But we are going to draw some pictures on the top half of the flap. So go ahead and divide the top half of your flap in half as well after you're done copying down your theorems. Okay, so for our first picture, you're going to draw this rhombus. So we know it's a rhombus because they marked that all of the sides were congruent. Okay, and you need to label this corner up here as 36 degrees. You don't need to write the sentence above. Just draw the picture. And we're going to solve for all the missing angles. All right, so first of all, because it is a rhombus, we know that this angle where that 36 is has been split in half, right? So if the top half is 36, what's the bottom half? 36, okay? Where else am I going to have 36-degree angles? Right, the other part down here, okay? And also, because it's a rhombus, what kind of angles do I have all around here? 90. And then I can solve for the ones that are missing, right? Okay, so we know it's a rhombus because of all the congruent sides. We know we have 90-degree angles all around, like you guys just told me. Okay, and we know that the angles have been bisected. So just like you guys said, 36 has a 36 below it, as well as in this opposite corner. Oops. So we can subtract 36 and 90 from 180 to find the remaining angle in one of these triangles, which is going to be 54. And then for the same reason all of those were 36, all of the rest have to be the 54. So there's not going to be a lot of solving to it, but you just need to know your properties. Okay? All right, go ahead and draw that picture over there as well. Okay, it says we're going to find the perimeter of parallelogram ABCD if AC is 24 and DB is 10. Again, you don't have to write the sentence, just draw the picture and label AC being 24 and DB being 10. Okay, so because it has the properties of a parallelogram, what do I know about its diagonals? What do diagonals do? Bisect each other. So if AC was 24, what is each piece? Right. Okay. So we got 12s and 5s for each piece because of that rule. Okay, so now all I need to do is find the missing side, which is the outside edge across from my 90-degree angle. How do I find the missing side? Very good. Where we already know A and B, and we're looking for C, right? So we end up with 169 equals C squared, so what must C be? 13. And according to our properties, in a rhombus, all four sides are what? Congruent. So 13 times 4 tells me the perimeter must be 52. All right. Okay. We have one more that we're going to fill in. So flip to your squares. Okay, so for this one, everything that's on this next slide is all going to go on the square flap. So you can put this in the whole section for squares. Okay? So first of all, a square's properties are all the properties of a parallelogram. So the 5 that we already knew. The next is that it has all the properties of a rectangle. So remember, that was 2 additional properties, the 90-degree angles and the diagonals being congruent. Okay? And it also has all the properties of a rhombus. So those were those last few we included. That opposite sides were not only congruent, but all 4 sides were congruent. Okay? The diagonals are perpendicular. And then that's going to bisect those opposite angles. But because those are congruent diagonal pieces, it makes the base angles congruent. So they're both 45s and 45s, which is the exact proof that we drew for our 45, 45, 90. So make a notice here, we do have 45, 45, 90. So remember, in order to solve for missing sides in a 45, 45, 90, we can use n square root of 2, or x square root of 2, whatever variable you want to put in there. Okay. And then the last thing that we're going to add here is what it takes to prove that you have a square. Okay, and that's going to be this sentence here in red. So this says a parallelogram can only be a square if it contains at least one property specific to a rectangle and one property specific to a rhombus. So if you want to prove you have a square, you have to pick one rectangle property and one rhombus property and prove those 2 to prove it's a square. And we're only going to do one example picture. So on the top half of the flap, you want to go ahead and draw yourself a picture of a square. We're going to solve for one missing piece in our square. Okay, so you again do not have to write the sentence there at the top. Just draw this picture where it says it's got a walkway that goes diagonally across our square part, and it's 58 feet long. Okay, we're going to find the perimeter, meaning we got to find the outside edges. Well, what did this diagonal split my square into? Two triangles. Two what kind of triangles? Two right triangles where these two angles are both 45s. So we have a 45, 45, 90 triangle on both halves, basically, right? Okay, so those 90s were split in half, so we got 45, 45, 90s. Remember, in a 45, 45, 90, the sides across from the 45s are both x, while the hypotenuse is what we say is x square root of 2. So we would label it like this. Which piece did they give us? The x, or the x square root of 2? The x square root of 2, right? The one across from 90. And they said that was 58. So if I'm going to solve for x, I'm just going to set x square root of 2 equal to 58. All right, if I'm going to solve, how do I get that x square root of 2 away from the x? Divide. So this is what we end up with. But we don't want to leave that square root of 2 in the denominator, so what would we do? Multiply top and bottom by square root of 2. Right? And they didn't ask us to give it in any specific measurement, so you could estimate here to type in your calculator to say this is approximately 41. And if this is a square and one of its sides is 41, how would I find the perimeter? Times 4. That's it. Oops, sorry. Let me go back. So we would get about 1,682 feet as our perimeter, or 81 feet, depending on where you're around. Okay. So just a heads up that we have a quiz next week on Tuesday. We have now covered all the information that's going to be on it. So on Monday, we're going to do a little bit more extra practice over these three figures. And then Tuesday, we'll be taking our quiz.